In this lesson, we're going to talk about multiplying special cases, but in this time, I should be able to recognize these patterns. Now, honestly, some of these are more important than the others. The top two square of a sum, square of a difference, saves you a little bit of time. But the bottom one, that one's the key one. That one we're going to use a lot. Okay, let's get into it. First, let's talk about perfect square polynomials. That's when you see a square like that, a plus b squared. Let's keep in mind, when something is squared, you multiply by itself. 3 squared is 3 times 3, 9. The same thing works here. What we're not going to do is this. This is so bad. I hate it. All the math teachers hate it. That is not what you do. It's not a squared plus b squared. I don't even want to show it because I don't want people thinking about doing it. When you square something, you multiply by itself. That's what to hold here. It's a plus b times a plus b. And then you got to either distribute or do the area model. In this case, I'm going to do the area model real quick. AB, AB. We're going to get a squared, a times a. We're going to get ab. We're going to get ab, and we're going to get b squared. By the way, that right there, I could also done ba. So they're the same thing. Now, what you're supposed to do is put in alphabetical order. If you have b times a, and you get ba, technically you should rewrite it as ab. So there's no difference between these two. These are the exact same thing. Technically, you should write it in alphabetical order, but you will see that they're the same. Anyway, now you can add up like terms, and we get a squared. 1ab plus another 1ab gets me 2ab plus b squared. That's where you get the formula right there. That's where formula comes from. Basically, if you notice it's like this, you could just skip doing all the multiplication and it's going straight to this. It's the same thing for this one here. We can multiply them together, but we're going to get this the formula, which is the first one squared minus 2 times two numbers plus the last one squared. That's kind of the formula. You can see it there. If you memorize it, it saves you a little bit of time. These two are not as important, but that's what they're for. Instead of going through all this hassle here, you can just go, wait, oh, I see, it's a perfect square. It's going to be the first one squared plus 2 times both of these multiplied together plus the last one squared. Okay. Like here, this is to show what not to do. This is not 3x squared minus 4x squared. Not that. It's not what you do. When it's squared, you multiply by itself. 3x minus 4 times 3x minus 4. Right? We could do area model or we could distribute. I'm going to do the area model because I do think people prefer that. 3x minus 4, 3x minus 4. We're going to get 9x squared minus 12x plus 16. I can add these two terms here. They're both x's. I'm going to get 9x squared. And then negative 12 and then negative 12 is a negative 24x plus 16. You get that answer. Now, you could have done that, or you could have done the formula. If you remember, if you forgot the formula, we just talked about it. Write it right here. It is a squared plus 2ab plus b squared. How does that work in here? I'm going to square this guy. 3x squared. That's 9x squared. And then we're going to multiply a and b. We're going to multiply these two things. 3x times negative 4 is negative 12. But then we have to times it by 2. That gets us negative 24. And then we're going to square the last one. Negative 4 times negative 4 is a positive 16. You get the same answer either way. And you can actually do the same thing here if you want to. With this like a squaring, instead of trying to multiply 71, you could also just break it down to like 70 plus 1 squared. And then you use the formula. 70 squared is 4900. 70 times 1 is 70 times 2 would be 1400 plus 1 squared. You get all that. And then if you add it all together, you would get about 5041, like that. It's a niche case, but mostly it's for this. If you happen to memorize it and you want to put use to it, it will save you some time. But honestly, don't worry about it too much because you can just multiply them together and it's not too bad. But the one that will help you a lot is a difference of squares. That's this one. We have b times a plus b times a minus b. This is different than the last ones we did. The last two we did were they're squares, a plus b squared. Then this is x plus 2 squared as an example. This will be x minus 2 squared. Now we're going to have two separate ones that they're the same, but the sign is different. What happens when I multiply these two? Well, let's just do it. I'm just going to multiply these two. It's a big old area model. We have a minus b, and we have a plus b. I'm going to get a squared. I'm going to get minus ab. Remember a, b, ba, same thing. You should put it in alphabetical order. A goes first. The same thing here. A times b, ba. We'll put in alphabetical order, ab. And then I'm going to get minus b squared. Let me rewrite this real quick so you can see it. And what do you notice? The middle terms cancel out. I'm left with just a squared minus b squared. And that's why this one's helpful because it makes it shorter. If you have the same thing, a plus b and then a minus b, it doesn't matter which order, the middle terms are going to cancel out. You're just going to get the first term squared minus the second term squared. For example, if I give you x minus 3 and x plus 3, I could do the whole math. I could do it. It will work. Or you could go, wait, that's a difference of 2 squares. All it is going to be the first one squared minus the second one squared, which is going to be x squared minus 9. That one does save you time. That one is a very important difference, 2 squares. If you can't be bothered remembering it, it's not the biggest thing in the world because you could just do the area model or distribute and you get the same answer. But this one is Very helpful if you know it. Let's do a couple examples. Like in this case, I'm like, oh, it's a difference of 2 squares. Yay. So all we're going to do is the first one squared, 2x squared minus the second one squared. And I'm going to get 4x squared minus 16. And it's great. If you don't remember it, you could have just multiplied them. Area model. You get 4x squared here. You get negative 8x, positive 8x minus 16. These would cancel out, and you get 4x squared minus 16. So it works out either way, but it's a nice one. I like the difference of 2 squares. Don't worry about it too much if you can't memorize it, but it does make it a little easier. Okay, let's apply. Let's do an application problem. What is the area of a square image? The area of the border is 704 square pixels and is 4 pixels wide. Let's do that in black. So it's my square image. We're going to have a border that's 4 pixels wide. This is going to be 4. That's my border. Now, it is a square. Whatever this is, I don't know what this is. Let's say that's x. I can make this x also. What we do know is that this border here is 704 pixels wide. If I make this x, the reason we're making this x is if this whole thing is x, and we know this is 4 wide, that means that this is 4 wide, which makes this whole side x plus 8. This is x, the border is 4, that's 4, and this is 4. The whole side is x plus 8. And I can do the same thing over here. This is x, this side is 4, this side is 4. I have x plus 8. What we're going to do is we're going to do the area of the whole thing, which is x plus 8 times x plus 8, minus the area of the inside, which is just what, x times x. And that'll give us the area of the border, which we know is 704. That's this process. We're going to get the area of the whole thing, subtract off the area of the inside, and we should be left with just a border, which we happen to know is 704. That's the process. Let's put this here. This would be area of that guy is going to be base length times width, x plus 8 times x plus 8, minus the area of this guy. Well, this is length times width, which is x squared, equals 704. Now, these are the same things. We could do an area model, or we could use a shortcut. This is the same thing as x plus 8 squared, which is the first one squared, plus 2. We're going to multiply them. 8 times x is 8x, times 2 is 16x, plus the last one squared, plus 64. Like that. Minus x squared from right there equals 704. So it's a recap. Multiply these together. X plus 8 times x plus 8. I didn't divide. That was me showing, hey, that's the same thing as x plus 8 squared. We can use the formulas we just learned to get this. If you don't want to do that, just multiply them. X plus 8 times x plus 8. Distribute x squared plus 8x. Distribute 8x plus 64. Add them up. You get 16x. It works both ways. If you know the formulas, it does save you a little bit of time. Anyway, so right here, first thing we do is simplify if we can. And in this case, these x squares cancel out. So we're left with 16x minus 64 equals 704. Next, we'll add 64 to both sides. You get 16x is equal to 640. And then we just have to divide by 16. We get x is equal to 40 pixels. That is the length. That is the length of this picture frame. Now, what is the question? We want the area of this square image. So that area, I guess the question is, what's the area of the image? Let's answer that question. The area would be x squared, which in this case would be 40 squared, which would be 1600 pixels squared. It's always helpful to actually read the question, as I just demonstrated. The answer wasn't just what's x, it was what's the area of the inside. We know the area is x times x. Once we figure out what x is, we just multiply that together. Okay, let's finish off real quick. Let's do a couple of these. If I want you to multiply this, we can do it 2 ways. If you remember the formula, you're just going to go, okay, that's the first one squared minus this one times this one, but negative 7x times 2, 14x. I should say minus, it's just like plus, but in this case, you get negative 7 times x, so it's negative 7x times 2. And then you add the last one squared. And it's always adding because even if it's a negative, you're squaring it, which makes it a positive. That's a shortcut method. Totally valid. But also you just go, wait, I know how to do this. That's x squared minus 7 times x squared minus 7. So if you do the area model or distribute, doesn't matter to me, you get this. Add up like terms, and you get the exact same answer. It does not matter to me which way you do it. When you square something, multiply by itself, you get this, which gets you that. So either way it works. Same thing here. If you remember the shortcut, it's the first one squared, 4x squared, you have to square both of them, the x and the 2. And then you multiply them. 2x times 5 is 10x times 2 is 20x. And then the last one squared, plus 25. That's the shortcut method. You can also just rewrite it, and then you do the area model or distribute. We haven't done distribute enough. So let me do distribute. 2x times 2x is 4x squared. 2x times 5 is 10x. We multiplied this term by all the ones on this side. And then we do the same thing over here. Multiply that 5 times each of those. Plus 10x plus 25. A lot of people call this FOIL. It's distribution. We don't need a fancy name for it. You just distribute this guy to all of them, this guy to all of them. Anyway, as we said, like terms, and you get 4x squared plus 20x plus 25. There we go. And the last couple here, these are the difference of 2 squares. So this is one I think is actually the most helpful. Like you see them like, oh, difference of 2 squares. You go, all you have to do is multiply the first one, square the first one, minus square the second one. Done. right? X squared times minus 4 squared. Done. Don't like that? Feel free to do it another way. You're going to get x squared minus 4x plus 4x minus 16. These cancel. X squared minus 16. It works either way. And the last one I'm going to do here, just real quickly. I'm like, oh, difference of 2 squareds. Boom, boom, boom. All we're going to do is 3 squared, which is 9, minus 5 squared, 25. Or you can distribute. Or area model. If I was doing this, get that 3 times all of them. 9y squared plus 15y. Get that negative 5 times by all of them. I get minus 15y minus 25. These cancel. And you get 9y squared minus 25. Either way is valid. Either way is fine. If you know the formulas, they are a little faster. If you know only one of them, the difference of 2 squares will not do it. That's the video.